Alright, so in this video, I'm solving the equation x to the power of 3 is equal to 3 to the power of 3. So to solve this, I'm going to first start by subtracting 3 to the power of 3 on both sides. So now I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now from here, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this turns into x minus 3 times x squared plus 3x plus 9 is equal to 0. So now from here I get two equations. I get x minus 3 equals 0 and x squared plus 3x plus 9 is equal to 0. So obviously for x minus 3 equals 0, x is equal to 3. So this is one solution. And now for x squared plus 3x plus 9 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this turns into negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. And this turns into negative 3 plus or minus the square root of 9 minus 36 over 2, which is equal to negative 3 plus or minus the square root of negative 27 over 2, which is equal to negative 3 plus or minus the square root of 27 times the square root of negative 1 over 2. Now, 27 is the same thing as 9 times 3. And the square root of 9 is 3, so I get x is equal to negative 3 plus or minus 3 root 3. And the square root of negative 1 is actually equal to the imaginary number I. So these are two more solutions to this equation. Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3, because again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I have log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2, and I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution.